Okay, welcome to Mr. Lamb Science Corner. Today the element is silicon. I always feel like I should have a song or something for each one of these things, but I don't. I wish. Si is the symbol. Atomic number is 14. Atomic weight is 28.1. It has three stable isotopes, 92% of which is Si-24, as you would expect with a number close to 28. It has a grand total of 23 known isotopes. So there's a lot of, what they do is scientists get into a lab and they start working, they playing around, whatever you want to call it. And they create these isotopes. And you may say, well, why are they doing that? I mean, it's just, of what use is it? And the answer is oftentimes not really very much. But knowing how to do this is very important. And when much later we'll hit americium, which is a radioisotope only created, not found in nature hardly any at all, if any. We're talking about one or two atoms here or there. But if you want to produce any significant amount, you got to produce it. And it has a very important usage. And I'll tell you right now, it's found in smoke detectors. So a lot of lives have been saved by this so-called useless knowledge of how to produce radioisotopes. Not to mention the people who have undergone radiotherapy to kill cancer and other things dear to my heart and stuff like that. So it's hard to say. We used to have William Proxmire, Senator Proxmire, give. He made fun of some of this scientific stuff, and he never did see that there's knowledge for knowledge's sake, and sometimes it turns out to be really worthwhile. Anyway, I'll get off my hobby horse there. So, silicon was discovered by a man named Berzelius, and who is definitely going to be one of the people I talk about fairly soon, because he did a lot of things early in chemistry's life. You remember, chemistry, the father of modern chemistry was Lavoisier. Call it 1776 because it's an easy number to remember for us as Americans. And Berzelius discovered silicon in 1824. So within the lifetime of the start of modern chemistry. So anyways, it's the second most common element in the crust, oxygen being the most common, and 20% of the Earth's crust is silicon. Not found by itself in nature. Again, it's just one of those things that it always managed to combine itself with something, usually oxygen. Silicon dioxide is silica, and we call it by other names. Quartz, for example, rose quartz and things like this. It's also sandstone, because a lot of sandstone is quartz. Opal, my wife's birthstone, and favorite gem for her. Petrified wood, agate. It's also found in man-made objects. I always like this because it's special lubricants, so there's a lot of silicone stuff that acts as a lubricant because it's very slippery. And the one I like the most is silly putty, which was kind of an accidental discovery. But more importantly, and certainly the one that we want to pay attention to most, it's found as a basis for solid state electronics. You take some very, very, very pure silica, and you what they call dope it. You add in selected amounts of things like uh, germanium, arsenic, probably a little gallium. These elements down here. So here's silicon. You add a little bit of this, and uh, you turn it into solid state electronics. So what can you do with an electronic? Solid state electronic? Oh, you can make transistors with them. And transistors are the basis, and you find thousands, if not millions of them inside of things like your cell phone, your computers, rectifiers, which basically will take, let's see if I get this right, will take DC current and turn it into AC current, or I'll leave it up to you to find out. It could turn AC current into DC current. I think it turns DC into AC, but uh, it's called, I'll leave it as an exercise for the student. It's also found in solar cells too. So uh, the house of the future is is going to be probably a lot of solar cells. And does anyone think computers are going to go away in the next 1,000 years or so? You'll probably have computers talking to you like Star Trek and things like that, but they're still going to be there, and they still probably use silicon. So very, very, very important element. And with that, thank you very much.